This video is about how to solve exponential equations. An exponential equation is an equation that has a variable in the exponent. So like a to the x equals b might be, what's the power that you raise a to in order to get b? These are some examples of exponential equations. The first type of exponential equation is going to use this principle here, that if b to the x equals b to the y, that means x equals y. So basically, if you have the same bases and they're equal to each other with some powers, those powers have to be equal. So a very simple example would be, if 2 to the x equals 2 to the fifth, that must mean that x equals 5. Okay, so the trick to this method is you have to have bases that can be written as powers of the same base. So for example, I know 27 and 9 are both powers of 3. So I'm going to start by writing them as powers of 3. This is 3 to the third, parentheses to the x plus 3. And that's equal to 3 to the second, that's what my 9 is, to the x minus 1. And then we're going to use a power rule that says if you have a power raised to another power, you can actually multiply them together. So that will give us 3 to the 3 times x plus 3. And that equals 3 to the 2 times x minus 1. And now since we have these written as the same base, 3 to some power and 3 to some power, we can actually drop the power and just get 3 times x plus 3, drop the bases, and set our powers equal to each other. Just like that. So now we're going to solve this equation, and we're just going to distribute the 3 and distribute the 2. So we'll get 3x plus 9 equals 2x minus 2. And then we want to get all our x's onto one side, so I'll subtract the 2x from both sides. Get x plus 9 equals negative 2. And then we'll subtract the 9 from both sides to get x equals negative 11. And that is our answer. Now if you can't write your bases as powers of the same base, then you have to use logarithms. And a logarithm is basically the inverse of an exponential. So if you have an exponential equation like this, the logarithm would be the inverse of that. And it's basically the way to get the power out of the exponent. You could think of this log base a of b as the power that you raise a to in order to get b. So this is a big topic. You can read more about it online. But for now, we're going to use a very specific property of logs. So we're going to use the exponent property of logarithms. And this property basically says if you take the logarithm of something being raised to a power, that power can actually come down in front of the logarithm and become multiplied by the logarithm. So again, this is how we're going to use logs to get variables out of the exponent. This is the process we're going to use to solve exponential equations with logarithms. First, you have to get the exponential expression by itself. Then we're going to take a log of both sides. We're going to use that property to get the variable out of the exponent, and then we're going to solve for that variable. Okay, so in this example, we can't write both sides as powers of the same base, so we're going to have to take a logarithm of both sides. So we're going to do log of 5 to the 2x, and that will be equal to log of 137. And now on the left hand side, this 2x is going to come down front by that property, so we're going to have 2x times log 5, and that will be equal to log 137. And then we just have to get x by itself, so this is all multiplication over here on the left, so we're just going to divide by everything that's not x. We're going to divide by 2 log 5 and do that to both sides. 2 log 5. Because over here on the left, the 2's will cancel and the log 5's will cancel, and we'll get x equals. And on the right, this is our answer, log 137 over 2 times log of 5. If you throw that into the calculator, you'll get about 1.53 rounded to 2 decimal places.